So the first thing that we want to start off with is the null hypothesis. This is denoted by H naught or H sub 0. And the null hypothesis is simply a starting point, a benchmark that we can compare our study results to. We go out, collect data from a sample of participants. We compare our results to the null hypothesis. Without even collecting any data or analyzing any data, we assume that there is no difference, that there is no relationship between your groups or between your variables. If you had no prior knowledge about what causes childhood obesity, let's say you're a Martian, or you're just somebody who's been sleeping under a rock and really has no idea of what obesity is, besides that it has large body mass. But really, if you had no idea of what causes that, you would assume that between skinny children and fat children, or between boys and girls, or athletic or not athletic, that there's going to be no difference between them in terms of obesity, or between fast food consumption or fruit and vegetable consumption and obesity. But if we had no prior knowledge about this, we would assume that there were no differences. And really, if there were differences, it'd probably be due to chance. And so we really had to see whether or not the process of hypothesis testing to really see if we do see differences or relationships, that it's really not due to chance, but due to some other explanation. We'll get to that in just a few moments. So thinking about childhood obesity, a null hypothesis could simply be there are no differences between children who eat fast food regularly and children who do not eat fast food regularly on BMI levels. Or in this case, our independent variable is whether or not children eat fast food regularly or not, so fast food consumption. And our dependent variable would be BMI levels, whether in the form of underweight, normal, overweight, or in the terms of number. What is your BMI number? Or we can also look at relationships. The relationship between childhood fast food consumption, perhaps how many times do you eat fast food on a weekly basis, and BMI levels. So we can say that for a null hypothesis that there is no relationship between childhood fast food consumption and BMI levels. So notice that in the first hypothesis, the first null hypothesis, that we're stating that there are no differences between two different groups of children. Those two groups of children, one group eats fast food regularly, and the other group does not eat fast food regularly. Whereas in the second null hypothesis, we're looking at the relationship between two different variables. The first variable, our independent variable, would be childhood fast food consumption, and our dependent variable is BMI levels. We're trying to test the relationship between two different variables. So why do we even call it the null? Or what is the purpose of the null anyway? Or why do we use it as a benchmark to compare, or a starting point? Well, just like the court system, where you have to prove someone is guilty, otherwise you assume they're innocent, the burden of evidence is on us as a researcher to prove that there really is a difference between two or more groups, or that there really is a relationship between two or more variables. We have to go in with the assumption that there are no differences, or that there is no relationship. This is the basis for the null. And really, we can never be sure that a theory is true. Even though we test it and we test it and we test it, we never really know that unless we can repeat these research studies and we get the same answers and results over and over again, can we then say that yes, there is more evidence to support a theory. However, if a set of researchers find different results, those results can either disprove or refute the current set of knowledge. So we always have to improve upon our research studies, and this is why we see research being conducted prolifically, because we want to make sure that any types of results that we're trying to help drive theory or understanding behaviors, it's really based upon sound evidence. It's based upon good scientific research. So again, it's our responsibility as researchers to collect evidence and try to really have a nice, clean, rigorous study design so that we can reject the null. We're simply saying, no, there really is a difference, or no, there really is a relationship. So, aside from being able to make statements about a null hypothesis, we can also write equations to help us describe hypotheses. So when we're writing out a null hypothesis, already we saw null hypothesis can be written out as H naught or H sub 0. And really, because we're looking at two different groups, and this is really just looking at difference tests specifically. This is going to be your equations for difference tests when we're looking at two or more groups. So in this case, we're looking at two groups. And we see we have this backwards U, this U-looking symbol. This is what we call mu. And really, because we know the null hypothesis states that there are no differences between groups, we simply see that H sub naught, which is a null hypothesis, is saying that the population mean for group 1 is equal to the population mean for group 2. So one thing I want to make sure, a little side note, that whenever we're writing the null hypothesis, we're always using Greek symbols. In this case, mu is a Greek symbol. So whenever we're talking about the null hypothesis, we use Greek symbols. And the reason for that is we're always referencing the population. The null hypothesis is always talking about the entire population. In this sense, we're talking about childhood obesity. So maybe we're talking about the population of US children, and we're looking at children who eat fast food regularly and US children who do not eat fast food regularly. So thinking about that, what would you write your null hypothesis between children who eat fast food regularly and children who do not eat fast food regularly? How would you write out the equation, your null hypothesis equation, for this hypothesis? Well, we have our children who eat fast food, and we have children who do not eat fast food. And when we're talking about the null hypothesis, our equation should be that the population mean for children who eat fast food regularly equals the population mean in terms of BMI for group 2, for children who do not eat fast food regularly. And so whenever we use equations, when we're writing out our groups, we want to use subscript to help us denote what group is which. I've used FF for fast food and NFF for not fast food. You can really just use anything arbitrarily, but you want to make sure that you're using something that makes sense and that somebody who saw the equation can make sense of it given the context of your research question, problem, or hypothesis.